Okay, this is number 47, section 1.8, and what we want to do is we want to find the equation for f inverse of x, giving that f of x in this case, on number 47, is x plus 2 cubed. We want to find the inverse. Then we want to graph both f and f inverse on the same rectangular coordinate axes, and then use interval notation, give the domain in the range of both f and f inverse. So what we're going to do first of all, when we look at this, we use our regular four-step method to find the inverse. And first of all, we'll take f of x and change it to y, and then we'll interchange the x and y. So I kind of wrote this up already just to save a little bit of time. And then we want to solve this for y now. All right, so first of all, f of x to y, interchange the x and y, and then again we want to solve this for y. So I'll take the cube root of both sides, because I need to get rid of this cube because I want to get at the y. So the cube root of y plus 2 cubed is just y plus 2, and this is the cube root of x. I want to solve for y, so I subtract 2 from both sides, and now we've got it. And the fourth step is we call this f inverse of x. So there's your inverse function. Okay, so that was pretty easy. I think we know how to do that. And you'll have a quiz on this tomorrow. It'll be a little bit easier one than this, and then also a composite function. And then remember, we'll give you a code word a little bit later in the video, and then you write that code word right below your ID number. So if your ID number is up here, okay, then you would put the code word right there. Now don't tell anybody what the code word is, because the extra credit will be anywhere from 20 to 1 point. 20 points to 1 point. More people that have the code word, the fewer the points. So keep it to yourself. All right? And then hopefully you'll get a lot of points. Well, hopefully not, because hopefully everybody's watching this, but for your own sake. And I won't say anything about it, so I'll just say turn in your quiz. Don't forget your ID number in the upper left-hand corner, and you should know what to do. All right, and I'll tell you what that code word is in a little bit. All right, so let's take a look at this. Now we want to graph this. So what I did was I just made a table of values, and I put some values in here, and I figured out values that would work. Now you're going to get a little help when we see this, so I'll show you a little trick here. And I knew that if I put 0 in, I would get 2 cubed, which would be 8, so I started a little smaller, so I tried -4. And -4 plus 2 was -8. I'm sorry, -4 plus 2 is -2, -2 cubed is -8. Then I tried -3, -3 plus 1 is -1, and -1 cubed is -1. Then I put -2 in here, plus 2 is 0, 0 cubed is 0. Then I put -1 plus 2 is 1, 1 cubed is 1, and then I put 0 in here, 0 plus 2 is 2, 2 cubed is 8. I could kind of see what was going on. Now over here I didn't have anything happening to the x, so I just put my regular perfect cubes in it because I have to take the cube root. So 8's a perfect cube, the cube root of 8 is 0. I'm sorry, the cube root of 8 is 2. But 2 minus 2 is 0. I put 1 in here, the cube root of 1 is 1, minus 2 is -1. I put 0 in here, cube root of 0 is 0, minus 2 is -2. Then I put -1 here, the cube root of -1 is -1, and -2 is -3. And the last I put -2, -8, the cube root of -8 is -2, and -2 is -4. Now remember we talked about this before. If -4, -8 belongs to the function, -8, -4 belongs to its inverse, so this is a nice way to check these. So you can see how these points are just the same values but only reversed. Okay, so let's graph this now. I'll move this up so you can kind of see the values as I graph it. And I'll graph f in green. So first of all, for f I've got -4, -8, so I go 4 to the left, 1, 2, 3, 4, -8, all the way down here, because this is an 8 by 8. The next one is -3, -1, -3, -1. Then I go to -2, 0. Then I go to -1, 1. Then I go to 0, 8. All right, so that's my f of x. You can see that there. And we can, remember this is it's a cubic, x cubed, but it's x cubed just shifted over 2 to the left, because it's a positive 2, so it shifts over 2 to the left. And it goes like that. There we go, something like that. Okay, now let's look at the inverse function. I'll put those points down. And first of all, I have 8, 0, so I go x is 8, y is 0, so I go 8 to the right, 0 up. Then I go 1, negative 1, so I go out 1, down 1. Then 0, negative 2. Then negative 1, negative 3. And then negative 8, negative 4. And then we connect that. And this is our cube root. And it's only shifted down, it's shifted down 2. So this is the cube root of x shifted down. So this is real easy. It's just a vertical shift of negative 2. So those are your nice two graphs. And remember, they're going to be symmetrical. They're going to be reflected about this line. So this was just kind of a check of that. So when I put this line in, I find a couple points on this line. So I draw this line of symmetry so you can see what's going on here. This goes right down the diagonal. And there you go. So that red line is that the line y equals x, and that's our line of symmetry or reflection. And there's your function and the inverse. Now they also wanted you to write the domain of the range and the domain of f. Well, it's going to be all real numbers because even though this looks like it's kind of not going out very far, if you go high enough, it's going to go out to the right. So the domain and the range, because it's going to, you can see it's going to go up and down to infinity. The domain equals the range, and that both equals in interval notation, negative infinity, comma infinity. And then for the inverse function, this is f of x. This is the domain of f of x. And then for the inverse function, f inverse of x, the domain also equals the range, which equals negative infinity to infinity. And we know that the domain of the function equals the range of its inverse, and the range of a function equals the domain of the inverse. But since they're both the same, we can't really see much difference there. But they do equal the opposites of each other. In other words, the domain of a function equals the range of its inverse, and the range of a function equals the domain of its inverse. Okay, so I hope that helps. Oh, and I think the code word is cat, C-A-T, cat.